This is the second session of the 10 numeracy lectures. Multiplication and division techniques, including decimals. Right, now remember, the idea is to be able to perform these calculations quickly and accurately without the use of a calculator. In your pre-registration exam, which you will hopefully be doing in 4 or 5 years from now, you will not have a calculator to work with. So you will need to be able to do these in your head or having a method of doing it on paper. So long multiplication and division is not essential if you have a better technique that works. So if you're better at short division or chunking, that's fine. Please remember, for all of this, this is one of the methods of doing something. If you have a better way of doing the numeracy, then stick with it as long as you get your answer right at the end. So, double-digit multiplication, taking you back a bit, I'm hoping here. How can we multiply by 80? How can we multiply 80 by 70? It's easy if you can multiply 8 by 7. So, important note here, you need to know your times tables. You really need to know your times tables. There are apps available now that children aged 11 plus use, and these are to make sure that their times tables are up to date. I strongly recommend you get hold of one of those if your times tables are weak, and practice. So if we go to 80 by 70 here, you can split the numbers and rearrange the sum. So 80 by 70 is the same as saying 8 by 10, multiply by 7 by 10, 8 7s are 56, 10 10s are 100. So when you do the multiplication there, you would have got, go back one, 56, 5,600. Partitioning method, so if you had to do 84 by 40, this is the units and tens, remember? So you've got 80 there, 4 there, which gives you 84. And you've got 40 there. So 80 times 40, 8 4s are 32, and then the 2 zeros. 4 times 4 is 16, and then the 1 0. You add these two columns together, and you get 3,360. So this is the partitioning method. If I go back one slide, you've got the sort of double-digit method. Let's just do some practice, because there's no other way of learning how to do these things. So 62 by 20. These are your answers. 62 by 20. 62 times 2. Now I would do that, 62 times 2. I know 2 2s are 4, 6 2s are 12, 124, and the 0 goes on. You've got your method of doing 60 and 2 multiplied by 20 and then doing your 2 columns and doing it that way. 80 by 23. You should have got 1,840. 35 by 40. Should have got 1,400. 40 by 47. Should have got 1,880. 84 by 20 should have got 1,680. So again, whichever method you're using to get this calculation done, as long as it gives you the right answer and relatively quickly, you're on to a winner. So the partitioning method, if we work with bigger numbers this time, we've got 356 multiplied by 8. So 6 is the unit, 5 is the tens, so you've got 50 there, not 5. 3 is the hundreds, so you've got 300 there. So you then do 300 multiplied by 8, which gives you 2,400. 50 multiplied by 8 gives you 400. And 6 multiplied by 8 gives you 48. You add these 3 columns, that's the 2,400 with the 400 with the 48, and you get 2,848. So of course, we're going to practice that. Give you 2 minutes to get 205 by 4, 3 by 4, 4, 7, 5, 3, 5 by 9, 6 by 6, 2, 1, and 604 by 7, sorry. Okay, so 205 by 4 gives you 820, 3 by 447 gives you 1341, 535 by 9 gives you 4815, 6 by 621 gives you 3726, and 604 by 7 gives you 4228. So let's make them slightly more complicated. This time you've got double digits on both sides. So you've got 76 multiplied by 78, doesn't matter which one you put on what side. So if you put 78 there, you've got 8s and 70, 76 there, so you've got 70 and 6. You then multiply these two, 70 by 70, 7 sevens are 49, 8 sevens are 56. You then do 70 times 6, 8 times 6. You then have to add these two columns up to get the 5,460, these two columns up to get the 420, add the 48 to get the 468. You then have to add 5,460 by 468 to get 5,928. This is the partitioning method. Other people will have other ways of doing this, and that's absolutely fine, whatever works for you. So the same technique, but extended further, so therefore you can apply this technique to no matter how big your numbers are. So I could give you a 7-digit number on each side, you would just have the right number of columns on either end, and you need to do all the cross multiplications, all the additions, all the final additions, and you get your final number over there. So it's remembering to get it right. So the accuracy is crucial here, to get the right number of zeros, hence the multiplying by the zeros by the hundreds and thousands and tens was so important from session 1. So you need to get the right number of zeros, you need to make sure you put them in the right columns, and then again you need to make sure you add the right numbers together. So accuracy is imperative here. If we look at some decimal multiplication now, so those are all whole numbers so far, but what if we threw some decimals in? And to be honest, we will be throwing some decimals in, so you will need to know how to do this in your head without a calculator. So if we said do 17.8 by 3.5, this will be one part of a sort of calculation that you'll have to do. So if that required you to do 17.8 by 3.5, the first thing you should do is get an idea of approximately what size your answer is going to be. 17.8 is quite close to 20, and 3.5 is quite close to 4. So 20 times 4 is 80. So you should know whatever answer you end up with, which is obviously going to be a decimal number, is going to be somewhere near the 80 region. So if it comes out to be near the 800 mark or the 8 mark, you've gone wrong. So it's important to do this in your mind quickly to have a rough idea of what size number you're looking at when you finish with this calculation. So you've got 10, 7 and 0.8. That makes your 17.8. The 0.8, the 7, which is a unit, and the tens, which is a tens. You've then got 3.5, so again 0.5 and 3. Same method, 10 by 3, 7 by 3, 0.8 by 3, remembering where the decimal point goes. 10 by 0.5, again, important where the decimal point goes. 7 by 0.5 and 0.8 by 0.5. Decimal points, crucial, crucial, crucial. You get this right at this stage. So this now hopefully is further explaining why session 1 was as important as it was, because you will need to be able to multiply and divide by hundreds, thousands very easily and frequently. So once you've done that, you add up the parts to give you an answer of 62.3, which is nearish 80. So it's the same size. If that had come as 622.3, for example, then you know you've done something wrong with the decimal points over here. Or if it had come as 6.233, then again you know you've done something wrong because it's not near the 80s mark. So it's in the 80s mark. So, alternative method. You've got 30 times 4 that needs to be done. Sorry, this is a question. 32.6 times 3.7. You've got to work that out. So 32.6, do the calculation as 326 times 37 using the standard column methods. Your estimation, which you mustn't forget, that's near 30, that's near 4. Your answer should be around the 120-ish mark. So you've got 326 by 37. Remember, we've got rid of the decimals here. You do 6, 3, you multiply these as you would. So 6 sevens are 42, 7 twos are 14, add 4 gives you 8. Carry that over, 7 threes are 21, add the 4 gives you 22. You then add the two columns together, which gives you 1, 2, 0, 6, 2. Now at this stage, it's very common that students say, okay, the answer is 12,062. No, because you've forgotten your decimal points. You need to put them in the right place. Now where are you expecting the decimal to be? Because you can see that your estimate said your answer needs to be near 120. Therefore, your decimal point needs to be near 120.62. That's correct because you've got one decimal point here, one decimal point here. Therefore, it needs to go to the left by 2. So, if we had to do division by chunking, let's say we ask you to do 64, or the question requires you to do 64 divided by 4. That's your long division method. For 10, if you got the 1 there, because you're making that a 10, so you're saying 4 tens are 40, you get 24 left, and 6 lots will give you 24. That means there are 16 lots of 4s in 64. Another slightly longer, more complicated one. If you had to do 272 by 8, again you're saying 10 eighths are 80, 10 eighths are 80, 10 eighths are 80. We need 3 lots of the 10s. And then that leaves you 32, and 8 times 4 is 32. So 4 lots of there, 10, 10, 10, and 4 added to gives you 34. So there are 34 lots of 8 altogether, giving you the answer of 34. Now let's move on to multiplying decimals. So if we had to do 0.3 times 0.05, 3 5s are 15. There's 1, 2, and 3 decimals there. You move that 3 decimal places to the left, and you get 0.015. Let's try another one. 0.04 times 0.03. 4 3s are 12. Then you count 1, 2, 3, 4, 5. And you've got to move them along. So it's 1, 2, 3, 4, 5, and you get 0.00012 as your answer. Again, you can see it's very, very important that you get the decimal in the right place. So have a try of this. 0.5 times 0.007. And I'm hoping the answer you got was 0.0035. Okay, so when you're multiplying by decimals, what we're saying is you rewrite them as equivalent calculations as simplified as much as possible. So 200 by 0.007 is 200 times 0.007, or 20 times 0.07. Got rid of one decimal point from there. So you divide it there, so you multiply there. You do the same thing, divide one more there, multiply there, and you get 1.4. Same way, 300 by 0.007 is the same as 30 times 0.7, same as 3 by 7, so you get 21. So, have a try at 40 times 0.008. That would be the same as 4 times 0.08, which is 0.032. Okay, now let's try something a bit more complicated even. 87.4 divided by 19. Approximate answer is the first thing we want to do, remember, the estimate. So that's 90 divided by about 20, which is approximately in the 4.5 region. Choose a technique that works for you and answer the question. Don't forget the decimal point. Okay, and hopefully you got the answer of 4.6. So decimal division, one more, dividing decimals, 0.006 divided by 0.2. Writing this out as equivalent calculations, 0.006 divided by 0.2 is 0.6 divided by 2, which is 0.03. Same way, if you had 0.4 divided by 0.01, 4 divided by 1, 0.1, and therefore it's 40 divided by 1, which gives you 40. So have a try at 0.45 divided by 0.009. It should have come to 4.5 divided by 0.09. Again, you move that one more place to the right. Takes you to 45 divided by 0.9, which is 450 divided by 9, which is 50. If you try some more dividing decimals, 300 divided by 0.5, rewriting it again, it's the same as 3000 divided by 5, which is 600. Another one, 5000 divided by 0.002, is 50,000 divided by 0.02, which is 500,000 divided by 0.2, which is 5 million divided by 2, which is 2.5 million. 2,500,000. So have a try of this one. Okay, this was quite straightforward. 4,000 divided by 4, which is 1,000. 4.8 divided by 300. Rewrite that as an equivalent calculation. You get 0.06. If you do 0.38 divided by 20, again, you can see that you're moving it to the right. 0.38 becomes 2 divided by 2, which gives you 0.019. And the last one to try, 45 divided by 3000. And your answer should have been 0.015. Now, why is all this important? How are we going to use this? Where is this calculation going to come in? So to put it into context, I'm going to show you what's called a master formula. You will be given something like this, where you're told that the formula for a cream, calamine cream in this case, is this. You need 4 grams of calamine, 3 grams of zinc oxide, 6 grams of wax, 30 grams of oil, and 57 grams of purified water boiled and cooled. You would then be told something like this makes 100 grams of cream. How much of each component would you need if you have 10 grams of calamine? And how much cream would this make? So what the question is now saying to you is that this formula, when you put this all together, you will get 100 grams of cream. I don't have 4 grams, I have 10 grams of this ingredient here. I want to make the cream with 10 grams of this ingredient, therefore proportions come in. And you need to work out how much of each one that you need to make, how much of the other ingredients you would need if you were using 10 grams of calamine. And you also then need to work out how much cream this will make. Try and see if you can do this. I'll give you a minute to do that. Okay, so having a look at this question then, this is the formula. We're saying we've got 4 grams of calamine to 10 grams that we've got. The relationship between 4 grams and 10 grams is 2.5. You've got 2.5 times the amount of ingredients that you had. So therefore everything needs to be multiplied by 2.5. You can make 2.5 times more of the amount of the cream. So therefore it's 3 times 2.5 for the zinc oxide, 6 times 2.5 for the emulsifying wax, 30 times 2.5 for the oil, and then you can work out the total quantity. So you need to be able to multiply these decimal numbers and get the correct answer. For 57 times 2.5, you may need to get a pen and paper to make it work out. And the answer is 142.5. You need to then add up for a total amount of cream of 250 grams. You know that the formula makes 100 grams. So if you're doing 2.5 times 100, you do 1, 2, you get 250. So the total amount of cream you can make is 250 grams. You need to do these multiplications here to work out how much of each of the other ingredients you're going to need. And that's called a master formula. So this is why it's important to do the basic numeracy we've done so far, because that will allow you, or it'll give you the foundation, to be able to complete questions correctly and accurately in your head without a calculator of this nature. And this is what's going to be expected at the end of year 1. So you need to be able to do this sort of calculations quickly and easily. So remember to find the method that works for you, and then using that method achieve the correct answer.